My name is Ray Bachman. I'm director of the Nanotech Institute at the University of Texas at Dallas. Our new artificial muscles are based on carbon nanotubes. Carbon nanotubes are cylinders of carbon, and the particular type of carbon is the same type of carbon that's found in graphite, like in ordinary lead pencils. Our artificial muscles are based on carbon nanotube yarns. This is just a conventional yarn, but there's not a great deal of difference except for on dimensional scale between this ordinary yarn and our carbon nanotube yarn. When the wax inside our yarns expands, what it does is it causes the yarn to contract. And this contraction can be giant. And this contraction is one type of actuation we use for our muscles. Now, if I wind up the rubber band on this model aircraft, this is a twisted part of the rubber yarn, and this is the coiled part. This coiling is extremely important in our obtaining very high actuation for our yarn. These artificial muscles that we've developed can lift weights that are enormous compared to their dimensions.
The weight the artificial muscle is lifting right now, it's about 100,000 times heavier than the muscle itself.
We've powered these artificial muscles using a light flash, just from an ordinary 100-watt lamp. In this case, the light flash is causing the paraffin wax within the yarn to melt and produce actuation. What are the applications of these muscles? They're strong. They can contract, provide giant contractions. They can rotate paddles. We use the fact that we can weave our carbon nanotube yarns into textiles. Emergency responder has gone into a burning building, and the heat from the fire has increased the temperature of his clothing and causes the clothing to change porosity, so it provides protection against the flames. This intelligent materials function aspect is very important to us.